So this is machine learning infrastructure at Stripe. Going to talk about sort of how we kind of bridge the gap between scikit-learn and Python into the JVM. I'm not going to actually talk much about the modeling side. I'm not going to talk too much about the feature gen side. I'm more going to talk about like how we go from like, I have a model, I've trained it, I'm going to get this thing into production. Sort of what are some of the things that we do to do that. So hi, I'm Rob Story. I'm on the machine learning infrastructure team at Stripe. That's my really weird Twitter handle if you want to follow me on Twitter. So a lot of you might be familiar with Stripe or might use Stripe, but for those of you who don't, essentially the communication folks say, when I talk to people, I should say Stripe is a software platform for running an internet business. A lot of you probably know of us as like a payments platform, right? So if you want to sell some things, like build a website and sell some stuff, you can accept credit cards through Stripe. We also provide ways to like have really complex flows like that, right? So we can do subscriptions. We have a product called Connect, which is like marketplaces, right? So if you're Lyft and you say I have a driver and I have a rider and I want the rider to be able to send money to the driver, but I don't actually want to facilitate any of that. Like I don't want to deal with the money. We have things to say, all right, well, with these marketplace like things, you can actually send money from one person to the other and not have to have a middleman. The reason I like to say we're a software platform running an internet business is because we have things like Radar, which lets people set their own fraud rules. We have a new thing called Atlas that lets people from outside the US incorporate companies in the US and like get set up with a bank account and like a C Corp and all that. So if you have a startup or website and you want to accept payments, we can probably handle it. So I start all of my talks with sort of like a leading question, and the leading question, I think it's important for every business to ask, is like, why do I need machine learning? Like why does machine learning exist at Stripe? What do we use it for? So most of what we use it for is fraud. So I say merchant fraud here, like merchant is sort of a jargony term. Merchants are our customers. These are the people like you that would sign up to use Stripe, use the platform. Unfortunately, we have people who sign up for Stripe just to defraud us of money, right? So they're like, I'm going to sign up for Stripe just to steal a bunch of money from Stripe. So the trick is that we need to reject those account applications before they get through. B, we'd really like to reject them before a risk analyst has to look at it, right? Because we get a lot of applications every day, including some applications that are just people trying to defraud us that are automated. We'd really like to auto-reject those before like human set of eyeballs has to look at it just for like scaling issues. There's also a second type of fraud. I don't really want to call it fraud, but it does have to do with merchants. It's someone trying to sign up for Stripe that doesn't meet like our terms of service. So there are some things that we cannot sell or that we cannot process payments for. And a lot of those are restrictions from the bank. So like we can't sell guns, we can't sell drugs, despite them becoming legal in certain parts of the US. There's just some things that our banking partners say we cannot do. So like here's an example of someone that's tried to sign up for a Stripe account with the intent of defrauding us, right? They're like, oh, I'm going to make a website that has like literally a single product on it, like garden hose reel. So this is an example of like an actual fraudster saying, I'm going to make this like dubious thing to try to defraud the company. So the second type is transaction fraud, and some of you here might have actually like been victims of transaction fraud in the past. Joseph Soros talked about this morning. He said he started his career in transaction fraud. This is the sort of thing that we're doing where it's like the business using Stripe is legitimate, but someone is like charges are being made on the business's account that are not authorized by the cardholder. So if you've ever had like your credit card or debit card number stolen, that's qualifies as transaction fraud, right? Like someone buys 500 credit card numbers and tries to buy a bunch of stuff on Stripe before the cardholder notices. So we would really like to stop all of that theoretically. But it's really tricky because if you think about like the typical confusion matrix and like precision and recall, false positives are bad because we're blocking legitimate charges. It turns out that our customers really don't like that when we block legitimate charges. False negatives are bad because it's fraud, right? People are actually stealing money. So we have to actually be really careful about balancing the two. So the third type of ML that sort of we do at Stripe is like support tools. There's a smiley face here. So this is a lot of like text modeling, right? Where like for an agent who has to answer a support ticket, we make suggestions for how to answer that ticket or like categorize tickets, right? So they can work through the backlog. And the happy face is there because like happy agents, happy customers, right? The faster that our customer service agents can work through that stuff, the better. So I'm going to first start with like the serialization piece, and I think it might be helpful to just give a very high-level overview of what like Stripe's just like very top-down infrastructure looks like for serving a model. So we have like the internet. Then we have the Stripe API. That's all in Ruby. So let's say a transaction comes in. We go fetch some features from a database. We send the request with some of those features, so those are like live features, over to our scoring service. This is in Scala. We fetch some more features from Summingbird. This is sort of like a batch processing. It's half batch, half online that's doing counts and that sort of thing. If the model hasn't been loaded from S3 already, we load the model from S3. We score the prediction and send it back. And then our folks who are like our ML engineers who are doing all the training, so they're like on EC2 on some giant training box. And this is in scikit-learn, so they're training things in Python, sending those models to S3, also fetching the features for the things they're training from S3. So this is like a very rough overview of how machine learning happens at Stripe. All right, so right now we're going to do a terrifying thing because I hate doing live demos, but we're going to try it anyway. Which side is my cursor on? Okay, we're going to ship a model to production right now. It's happening. All right, I need that. So I need audience participation. I need 3 birds, 3 bird names, preferably not too long, please. So, what was that? All right. Kestrel, eagle. I heard crow. All right, I'm going with crow. All right, I need 3 planets.
Pluto.
I knew it. I knew it. I knew it. When I did this demo, when I was practicing this demo, I put Pluto in there without thinking about it. One more. Earth. All right, done. I need 3 foods. What? Taco. All right, perfect. Oh, no. Shorter. Cheese and pizza, done. Even though cheese goes on pizza, that's okay. All right, so this is basically, we're going to say, all right, so we have a bird flying on a planet, eating some sort of food. How far can that bird fly, right? So what you should note here is that most of this stuff looks like the typical scikit-learn that you've seen before. So we're generating this fake data set. We have a data frame. We have a series. We have this thing called multi-column label encoder. That is just your like regular label encoder that works with a data frame, right? So it's like a label encoder that works on every column of the data frame. Random forest regressor, you might have seen that before. Pipeline, it's just a normal scikit-learn pipeline, like no weird stuff going on. Then you see this sort of weird thing called make serializable. That's going to be the bulk of what we talk about. You can see that we, the PyData 2017 crowd, own this model, which is great, and we can fit the model. So let's see if I can copy paste this into a window. All right, so we fit it. Cool, now we need an observation. Let's go with a crow that eats pizza. Oh no, wait, pizza, all right, Pluto. A crow that eats pizza on Pluto. Planet Pizza. All right, so we have an observation. This is all still in scikit-learn land. All right, it can fly 538 bird units, whatever unit you want to say on that. Okay, so cool. Let's do this thing called toContentment hash, which is another thing that you probably haven't seen before that we're going to talk about. So this has to call out to the JVM, so it's like cranking. In the meantime, we'll go look at these functions. So what these 2 functions are doing is basically calling out to our scoring service. I needed to obscure like the actual host name of the scoring service, and I needed to filter some of the results because things like S3 buckets and things like that come back with it. It's probably not good to show on in a presentation that's being recorded. So let's copy and paste these into here. So sweet, we have 2 functions. We had a model ID. Cool, we have a model ID. So we have this big hash that represents an immutable model that's in S3 now. So in theory, we can score this right now. So let's get the model ID. Sweet, cool. So if we just like fetch some model data, we can see these are our features. These are the features we gave it. The model type is this simple bonsai regression forest. We'll talk about bonsai in a little bit as well. The model name is this giant hash of a thing. And then we, all of us in this room, own this model. So sweet, this is working so far. This is going great. All right, so we're going to get a prediction. We have a model ID. What was it before? So it was like, when we called predict 538 bird units, right? And that was a crow that ate pizza on Mars. So it's a crow that eats Pluto. That eats pizza on Pluto. And I hope we get the same thing. Sweet. 538 bird units. So this all actually happened like in Stripe's infrastructure right now. Like this is a model that if for some reason our ML engineers are like, we really need to know about this bird pizza Pluto thing, like they could load this model and it's like, it's living in the infrastructure right now. So good job team, we all just shipped a model to production. So awesome, let's talk about the pieces of that that sort of made this whole flow possible. So the first one is this make serializable thing. So we need to take this pipeline and we need to make it serializable. So this is the entire body of the make serializable function. There's not much into it. So this registry.makeSerializable is basically looking in this registry for the serializer that we need, right? So we take this random forest regressor and we have a little registry and it says, all right, do I have a serializer for the random forest regressor? Yes, awesome. I have a serializer. Let's take this serializer and do this serializable wrapper thing. So what is this serializable wrapper thing doing? Well, the serializable wrapper is actually a very, very, very thin wrapper around like just the existing scikit-learn stuff. So part of the power of scikit-learn is that they really like make they make all of their classes and that sort of thing very extendable. So if you look at this decorator, this if delegate has method decorator, this is all scikit-learn machinery, right? This is basically saying, all right, transform, delegate it to the underlying estimator. This basically makes like has adder work. There's some weird stuff going on. But this is basically showing like what we're doing is building this thin wrapper around scikit-learn, existing scikit-learn machinery that let us like have some other behavior. So what other behavior do we need? Well, our scoring service is written in Scala, which we talked about earlier. That scoring service gets a feature hash that's just key value pairs, right? It's just a map or a dictionary of key value pairs. So one important thing as this goes through is that we actually keep track with a data frame, which we require. So you see, we'll actually throw an error here if we don't have a data frame. All of our ML engineers and data scientists work with data frames 100% all the way through. We use the data frame columns to say, all right, these are our feature names. We need to keep track of those as we go through, right? Because we actually need to serialize the feature names as we move through this. And then we do this fit with feature names thing, which is just fitting, but keeping the feature names on the class so that we can serialize it later. So this is all just really thin wrappers so that we can keep track of feature names as like part of the data frame as we go through. So this is just a little bit of how we do it. But as an ML engineer, like you don't really care. What if you just want to ship a new model type, right? You're like, I don't want to use a random forest regressor. I want to use SVM or something like that. And I need to build a serializer for it. Like, what does that take? Or I want to like, not model type, but what if I want to build a new encoder, right? So let's say that you want to build like a new like imputation thing. You're like, I want to build the dumbest possible imputation thing. I want to fill all missing values with like a single value. It's like -1, right? So this is basically all it takes. This is like the machinery in our serialization, which is pretty simple. So we have this serialize function, right? We require that you get some bytes, right? And it doesn't have to be JSON. It can be anything, any bytes. All that matters is we get some bytes. So all this is, JSON to bytes is just like UTF encoded JSON. So we have some features and we have a value. And then we build this feature encoder thing. And the feature encoder, we require a few things. So we require the name of the encoder. This is so the Scala service knows, oh, this is the fill missing encoder, or the type of the encoder rather. Name is optional, but you could apply a name to this actual encoder. We require this pile of bytes and then an extension. So we're like, okay, this is a JSON encoder. Great. All right, well, we just talked about random forest regressor. This is the entirety of the serializer for the random forest regressor, right? So we have to go in to the scikit-learn estimator and like dig out the guts of this thing, and I'll talk about that in a second. And then we serialize this to this thing we call bonsai. And then we say, all right, it is a simple bonsai regression forest. We have this pile of bytes, and we have a bonsai file type. Quick aside, what is this bonsai thing? That is weird. There are many ML things named bonsai, it turns out. We also have an ML thing named bonsai. But it's an open source ML thing that you can use if you'd like. Basically, it's a compressed tree. So one of my coworkers, Tom, wrote this like very clever library to compress trees. Previously, our trees were in YAML. There's a lot of memory overhead in using that. So it's a Scala library that we actually shell out to from Python. To compress this trees, we get this little .bonsai file, this nice little file, and that's bonsai. You can go take a look at this right now. All in Scala, all open source. So that's bonsai. Aside over, I talked about diving into the guts of this thing. So we need to extract the structure of these scikit-learn estimators out. So this is us extracting the structure of the decision tree regressor, right? So this works on scikit-learn version something point something something. The problem with this is this kind of thing is like brittle to version changes, right? I'm actually pretty sure that the next version of scikit-learn breaks something in here in some way, because I tried it recently. So this is the downside of like reaching into the actual objects in scikit-learn and trying to like build a serializer from them, is without like an official API, it's super brittle to version changes and changes between scikit-learn versions, because like they don't make guarantees about internal APIs, and they shouldn't, right? But that does mean that this sort of thing can break between versions. So we went over that our models and our encoders all know how to serialize themselves, right? So we just went through the code where we say an encoder has a serialize method. It knows how to serialize itself into some sort of encoder or model type and some bytes and some extension. So then we do this weird thing called toContentment hash. So we're clearly hashing something, right? So what are we hashing? We're hashing this thing that we call a model package. So there's actually not a whole lot to the model package. So when we shipped our model live to production, we had an encoder. So we had this model package with an encoder, and we had our model. The encoder type was a categorical encoder. That's what we did with the label encoder. The model type was this regression forest. And basically this package, there's not much to it. So there's sort of this metadata file that says, okay, this is our encoder, this is the encoder name, this is the model name, this is who owns it. In this file that we end up zipping up, this is what label encoder.json looks like, right? Label encoded values, it's exactly, these aren't the exact ones we use, these are the ones I used when I first tried this thing. But same thing, right? We have that bonsai file, which is looks like that, right? So giant pile of bytes. So we have this model package, we have these files, we have this metadata file. And then we zip it, so we have a zip file, and we send it to S3. And contentment, so we say toContentment hash. Contentment is a little library that uses S3 as like a content address store, right? And so the nice thing about content addressing is if we know the hash for this thing, then we know where it lives, right? So we call toContentment hash. We have this hash. This is like the immutable snapshot of this model because remember we hashed like the whole thing. We have the encoder as JSON. We have the model as either JSON or this bonsai thing. We hashed the whole model package. So we have an immutable snapshot of this thing in time. If anything in there changes, the hash changes, and we have a totally new model in S3, right? So if we know its hash, we know exactly which model that we just built. So that's great. Like immutability in this case is very powerful. So great, so we have this model that lives in S3. Well, how do I actually promote it to production, right? Like we have it in S3 and it's great, and I can actually load a prediction and like score the model. But how do I tell the production service like, hey, I need that model. Like I want that model to be my production model, right? So we have this thing called model deployers, like, it does what it says on the tin, right? So we go from like having, so basically if you look at like the route, what we did before is we called like /model / the big SHA, the model ID, called and prediction. We go to that from having a tag. And basically a tag is a pointer to a model ID, right? And the nice thing, actually go forward one. So the nice thing about tags here is that like you can advance the tag forward, right? So we actually have an internal page that basically looks like this. So we have like this model was deployed at this time and the tag pointed to this ID, right? And this model is deployed at this time and the tag pointed to the model ID. It's basically a history of our deploys for models. But the nice thing is you can build tooling that looks like this around that deployment to say, all right, I want to deploy my transaction fraud model to production. I want to deploy this model. What it does is it basically like swaps out the pointer underneath, right? So now the transaction fraud production tag points at that model. The nice thing is though, if you like ship this model to production, you're like, oh no, I've made a huge mistake, right? Something is clearly going wrong. You can run this command. It'll give you the whole history of models you've ever run, and you can just like say, use the last one, like roll back. So what this does is it lets you move shipping models to production in the same way that like you'd ship a service to production, right? lets you go from just like sort of being like, all right, we're just going to overwrite the old one, to actually having a history of deploys and like feeling better about your deployment. Not as scary, right? In the same way that you want to ship services in like a not scary way that you can roll back, you want to be able to ship models in the same way as well. So that's great, but like still hot swapping these models on the fly into production like sounds scary. What if I actually want to give it a trial run? Like I'd really like to score a couple models side by side before I decide to put this one into production. So this uses this thing we call shadow models, like shadow. I don't know why I don't know why they called it shadow models. It's a cool name. Where basically we have this model hierarchy, right? So we have a model that fans out to multiple other models. So if the prediction service calls this model, it'll actually fan out that request to these three models, return all the predictions, and then either aggregate them or just log them, right? And so we have this shadow service. We essentially have a service that runs in parallel for candidate models where we can fan out to a bunch of candidates, log all their responses, and say, okay, like, is one of these actually ready to go into production? And then we have tooling around that that's the same sort of thing as I showed before, right? So you can add a model to Shadow, you can pull models out of Shadow. And this is happening really often with our ML engineers, just like putting candidate models in Shadow, seeing how they fare, pulling them out, or promoting them to production. So, talked a lot about the Python side. Haven't talked too much about the JVM bits. And some of you might be wondering, great, can you like give me a turnkey solution to like, can you open source the Python thing and then what Java thing do you use? The bad news is we actually implement everything on the Scala side, including the encoders. So the training is actually the really hard part, right? Doing the actual like evaluation, like something like a linear model, pretty straightforward, right? All you have is a couple hyperparameters, that sort of thing. The evaluation is like much easier than the training side. So, implementing an encoder, I think this is our category encoder. In Scala, like doesn't take that long. It takes a couple days. So we've basically implemented everything on the Scala side ourselves. I'd be interested in hearing after the talk if any of you have any like open source Java or Scala projects that you're using to do this sort of thing. But basically, like we've got trees and linear regressions and that sort of thing all implemented on the Scala side. Some components of this are open source already, mostly tree things. So I talked about Bonsai. The other tree thing, like we have a library called Brushfire that's basically like distributed decision tree ensemble learning. This is all of the random forest stuff that we do. And it is all open source. So like our service is calling into these libraries to build up these random forests that we use in production. I just wanted to put this slide up here as an example of like the serialization and scikit-learn like story is kind of fractured right now. Spark uses PMML. There was a talk yesterday from the HomeAway folks. They also use PMML. For those of you who don't know, Apple Core ML, when they announced their Core ML library, they sort of quietly also released a Python library that's a scikit-learn to protobuf serialization library. I think if it had existed a couple years ago, our team probably would have ended up using it. But we ended up sort of rolling our own stuff. It's mostly JSON. We talked about the Bonsai thing. I'm also interested in hearing from folks about whether, so if you think about it, we have this Python library that serializes things. We have the Scala side, which like does all the evaluation and predictions. I feel like there's not a lot of value in open sourcing the Python side without also open sourcing the Scala side that can read these serialized models and encoders and actually serve the predictions. But I've sort of seen that in the past, like there hasn't been a ton of success in like open sourcing these giant systems, right? Because usually you'll have requirements, especially around feature fetching, that system does not solve. So it's kind of tricky. So quick talk. That's basically it. Happy to answer any questions. That is sort of like the high level overview of how we put machine learning into production at Stripe. So thank you all. Questions? My moderator's not here, so I wonder if this microphone works. You can just yell at your question. Yep.
I was just wondering if the way you handle the models is Scala, why not building the single models in Scala as well? You have ML.
Yeah, that's a good question. The answer is that like the ML and data science folks like really like working in scikit-learn like a lot because it gives them, like as a lot of you all probably know, it gives you a ton of flexibility in terms of like tinkering with different model types. and like we're getting into more NLP things for certain text modeling applications, and like Python's NLP story is really good. It seems like on the Scala side, it's a bit more fractured, like Spark is there, right? We could use Spark, but sort of, and that's also a story of how this happens at a lot of companies where like Stripe was smaller, the team started using Python from the beginning, got very used to working in Python, and like as we hired more and more people, like those people were used to working in Python. So I think that's largely it. It's just like the engineers like using scikit-learn because it's really good, right? So, yep.
So you've got a system where you're serializing models and shipping them over and then running them in production and serializing them. Did you ever just look at serializing like the container? Or instead of serializing, just shipping a container that actually executes the model?
Yeah. So we're sort of looking like, I think Stripe spun up its first Kubernetes cluster this year, right, recently. I think the future is probably moving to more like, containerizing something and shipping a container to a cluster. We're about to do that with training. As far as serving, I'm not sure, we haven't talked about it much. We're definitely about to like move to containers for training. We're just like dump a container as a Kubernetes job and train that way. But we're not quite there yet, like on the actual production side. Yep.
You kind of half answered my question there, but so does your whole data science team use Python? Nobody uses R or anything else?
Yep, everyone uses Python. There is a little bit of Spark now, but it's like it's like one person, right, using Spark. So everyone else uses Python. Yep.
See any issues with this approach that you have in terms of now it's constraining the types of models you can actually use, and if you wanted to go to like TensorFlow or something, you have a problem?
Yeah. So we're constrained now on like developer resources, right? Because we have to go in and develop, like we need to go into the Scala side and actually implement this stuff. I would say like our infrastructure is not quite good enough yet, even to like enable TensorFlow stuff on the training side, right? So it's a little bit like fixed on scikit-learn, which is not good. And we're moving towards like letting people to sort of like bring whatever model you want. I think we'll still have to implement it on the Scala side. Luckily, with something like deep learning, like the training is hard. Once you have the training, it's a matrix of weights, right? So it's a little bit easier to actually evaluate that thing. So the story for the evaluation side is not too bad. We just like implemented an SVM a couple weeks ago, and it actually didn't take too long, so it wasn't too bad. Yep.
How fast is the evaluation compared to using scikit-learn to evaluate in batch and in?
Ooh, good question. I mean, so you're talking about the actual scoring of the model itself. I mean, this happens for every transaction that goes through Stripe's infrastructure, and we have pretty hard bounds on like how a lot of latency, right? How much time we have to return. It's like in the hundreds of milliseconds, right? So yeah, and it has to happen in real time because like we need to score transactions in real time. It's really, really fast. I'm not sure if we've actually looked at it that closely compared to scikit-learn because we're not too worried about it. Like usually we just train the model in scikit-learn and we do all the prediction in the Scala side. So yeah, good question, but we haven't looked at it too closely.
You do prediction scikit-learn in batch, it's really fast.
Yeah. One thing we have talked about, like right now on the Scala side, everything gets scored live, but we're actually talking about like having like an asynchronous endpoint because like there are some cases where you don't need to score everything live, where you can just run things in batch, or where the customer being like the Stripe API on the other end actually doesn't need an immediate answer back. Especially so we talked about like the candidate models. Like right now we score the candidate model at the exact same time that we score the production model. Like we don't actually need to do that, right? Because someone's just going to go look at that candidate model like every day or every other day. So that's the sort of thing that like we could move into like async batch scoring that we probably will do in the future. Yep.
Can you talk a little bit more about the shadow candidate models? Are you serving live traffic with those, or are they just sort of hidden behind and only the developer can look at the results?
Yeah, so live traffic does go to the model, but no response is returned. We just log it. So it goes to the model. We return the response to the service that's calling it, and then just log that response so that we can aggregate it later and say, all right, how did this thing do compared to the live production one? But yeah, no response is actually getting back, getting outside of Stripe infrastructure. It's basically just getting logged. Any other questions? Yep.
When you do models, you do a lot of feature engineering through all these transformations. Does all the transformations need to be available through the Scala API that we built.
Yeah, so the question is about features. You have a lot of transformations, right? So you saw that, and some of these pipelines can be pretty complex, so we can have like 5 different scikit-learn feature transformers or whatever. So the answer is yes, that when we ship that model package, all the transformers are actually shipped as part of it. And on the Scala side, we basically build like a parallel pipeline. We're like, all right, we've got 5 transformers this thing needs to go through before it actually hits the model itself. So the answer is yeah. Other questions? Yep.
If you're re-implementing the logic for some of the models and featurization on the Scala side, how do you test to make sure the results are coming back the same?
Ooh, that is a really good question. And I'm going to be honest, and I'm not. So that is something that was built before I showed up, but I don't actually have the answer for you to how do we test that the two are the same. That is a really good question, and one that I'll take back though, because a lot of this infrastructure was built before I came. Like the reason I can be somewhat effusive about it is because I actually didn't build a lot of it, so I can be like, my colleagues did a great job and had some good ideas. So good question. I honestly don't know off the top of my head. All right, any other questions?
What about keeping the Python stuff in Python and having the JVM just call out to it over protobuf or something like that?
Yeah, so this is sort of a political organization thing, in that Stripe is really interested in like not becoming a massively polyglot organization. It's like really they want as much stuff in Ruby as they can get in there, right? They want most people working in Ruby. On the data side, we do have a lot of Scala things. A lot of that's because like the JVM has the best tooling for Hadoop and that sort of thing. I don't think at an organizational level, like we're super interested in putting Python services in production. And I think that's probably the answer. Is that like for training and for actually doing some of the ML stuff, it's fine. But if we start putting services in production, I think we might get a little bit of side eye. I think containerization in Kubernetes could change that a little bit. I think if it's easy to ship a container and do that sort of thing, then maybe. But that's largely why. It's just like organizational constraints. So, any other questions? All right, thank you, everybody.